1 for the finishing of quantitative plating experiment. And here I need to talk about our third quiz, which was 15 points and 10 minutes timed. And after finish the quantitative plating, before finish the quantitative plating, I need to talk about our performance quiz. Our midterm performance quiz would combine to our final practical exam, which was total 30 points. So for finishing the quantitative plating, you know this is a method to count the cells, and you know the advantages and disadvantages. Advantages of using quantitative plating to count the cell is by counting the live cells. You know they are all live, not dead cells. So this is a good method. And there is maybe disadvantages by viewing the slide shown here. You probably gonna see two cell view colony forming unit clustered to one dot. So you probably gonna count two colony forming units one time. So this would be the disadvantages when you have the overhead view to count the cells. So this is the only disadvantage we are going to talk about. Another thing we want to say is we want to count the cells between 30 and 300 colonies on one plate. So this is really important for statistical significance, and we are going to find the best plate to count. If the colonies is less than 30, that's fine, we could count at least, but if that's more than 300 colonies, we'll write as TN, say too many to count, and we won't count cells more than 300 colonies. So for the table showing you here, this is important for the result of your quantitative plating lab report. For your lab report, I would like you to have a table exactly the same as shown here. And we have two sets. We have one pasteurized milk samples, which we set in the 33 Celsius water bath for 30 minutes. So this is a method we call pasteurization. Unpasteurized room temperature, and we do the series dilution, 10 to minus 3, 4, 5, 6, 7, and we do the series dilution to these two different sets of milk samples, and then later we are going to count number of colonies. After we count the number of colonies, we are going to calculate CFU per ml. I believe you know CFU per ml indicates the colony forming unit, and we are going to know the concentration of our pasteurized raw milk sample and unpasteurized raw milk sample. By doing the average CFU, so we are going to add all the concentrations together and divide by how many samples you used. If we have the best colonies between 30 to 300, for example, from this two plate, we are going to add these two concentrations together and divide by 2. If we added up 3 numbers, we are going to divide by 3. So this is a way to get average CFU per ml. So after I introduce you the example calculations, if you have any questions, you should attend your TS or virtual office hour, or email your TA to get a more clear idea of how to calculate CFU per ml of bacteria concentration. So after we finish the counting the cells, we are going to know a concept of a dilution factor. So dilution factor is showing you get an idea. Dilution factor equals 1 divided by dilution you used. If we have 10 to the minus 4 plate, our dilution factor would be 4. So this is the idea I want to give to you. For example, we have CFU per ml concentration. That is the equation we keep in mind. And this is something I would like you to keep in mind. This equation, number of colonies you count from your plate, that should be between 30 to 300 for statistical significance to get the bacterial concentration. After you count the number of colonies, you are going to multiply by the dilution factor. If you have 128 colonies from your 10 to the minus 4 plate, 10 to the minus 4 plate, so you are going to multiply 128 colonies, multiply by 10 to the 4. So this would be the final concentration of your 10 to the minus 4 plate. So there are this many bacteria cell colony forming unit present in your 10 to the minus 4 plate. So this gives you an idea of bacteria concentration calculation. How to do the average CFU per ml would be like the example shown you here. 30 to 300 colonies for statistical significance. And the example figure table showing you here, okay, 30 to 300, I'm going to use this plate. 30 to 300, this plate is okay. How about this one? It's less than 30, I won't use this plate since I already have two plates between 30 to 300. So I'm going to use these two plates. I am going to get the CFU per ml. So here I am going to have 374 times 10 to the 3. So this is my CFU per ml concentration of my 10 to the minus 4 minus 3 plate. And let's move on to do the calculation of this one. You know, I'm going to write 67 multiplied by the dilution factor 10 to the 4. After finish this, since this is less than 30, I'm not going to use this one. 0, I'm not going to use this one. I'm not going to use this one. Too many to count. Not this one, not this one. Oh, more than 300 and less than 30. Less than 30, what should I do for this? So if it presents you more than 300, well, since there is no good number for me to utilize to get my average CFU per ml for my unpasteurized raw milk sample bacterial concentration, I'm going to directly use this 3. Okay, I'm directly use this 3 to do the calculation 10 to the 5th, and this one would be 10 to the 6th. This one would be 15 multiplied by 10 to the 7th. So after I finished filling this column, I'm going to get the average. So since I'm going to calculate average would be only one number for your either pasteurized raw milk sample or unpasteurized raw milk sample. So let's have a look over this one. How to do the calculation is by getting the same notation. So an easier way to do, you could use your calculator, that's fine, but an easier way to do the average CFU per ml is by getting the same notion. I'm going to get the same notion, probably here is 5. Add up to 670 multiplied by 10 to the 3. So they are in the same notion. So as long as they are the same, I'm okay to directly add these two numbers together and multiply by the 10 to the 3 like this. I use the 2 plate. I'm going to get the average for this 2 plates, so I need to divide by 2. So this is an easier way to do the average CFU per ml is just get the same unit. And we are going to add them together. This would be 944 divided by 2. So please help me to see whether I did the calculation correct. These two numbers add together and then multiply by 10 to the 3 and then divide by the 2 plates I used, and this would be the final number, the average per ml for my pasteurized raw milk. And another thing I want to show you is we want you to write in scientific notion. So we need you to write 4.72 multiplied by 10 to the 5th. So this is the final average per ml, CFU per ml for your pasteurized raw milk sample. If I calculate it wrong, indicate to me, or we are going to move on. So you're supposed to know how to do the average per ml. Use these 3 numbers. We are going to talk about this concept again. So this is the easy way I just mentioned. If we have 2 plates, we need to do the average. We need to add these 2 numbers together and divide by 2. A very easy way to do the calculation is by having the same exponent. 35 multiplied by 10 to the 4 equals 3.5 multiplied by 10 to the 5th. And 70 multiplied by 10 to the 3 equals 2.7 multiplied by 10 to the 5th. So as long as we get the same exponent, it's very okay for us to add these 2 numbers together and divide by 2. And by doing this, we are very easy to get this average per CFU per ml for all of your samples. I assume you understand how to do the calculations because we are going to have a quiz questions related to the calculation showing you here. And our lab report also requires you to understand how to do the calculation, CFU per ml. And if you got any questions, please let us know. And we are going to evaluate whether our milk is in the range of our accepted limits for the raw milk. Unpasteurized raw milk sample would be 10 to the 5th CFU per ml. So that would be this colony forming unit present in the raw milk samples, and accepted limits for pasteurized would be 2 multiplied by 10 to the 4 colony forming unit per ml. So this is our talking about quantitative. So this is our unpasteurized raw milk sample after we mix the milk sample with our molten agar. Showing you here is 10 to minus 3 dilution samples. It's basically you see all the colonies. It's too many to count. I will not count this plate. How about 10 to minus 4? It's almost the same. Not only the big would be probably bacillus bacteria, and we also have these small tiny dots. That's also bacteria cells. So too many to count.
7, this is unpasteurized.
Yes, so they are all as shown you here. This is U. Later here, these are all unpasteurized raw milk samples. And for this one, it's the same. There are so many little dots that,
More than 300, I guess.
yes, more than 300, too many to count. How about this one? Well, I think this one probably okay. I have 10 to the minus 6. And how to count the cells is by using a Sharpie marker. When you count 1, you mark a dot. So you won't count 1 colony-forming unit 2 times. So I'm going to count. After I finish count, I'll show you the number. The cells, let just show you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 15, 16, 17, 18. So dear students, we finish counting the CFU per ml. The total number 112 colony forming unit present in these are 10 to the minus 6 plate. So you know how to get the CFU per ml for this plate. This is by this number multiplied by 10 to the 6. This is our dilution factor, and then we'll get the CFU per ml concentration of our 10 to minus 6 plate. And we have a 10 to minus 7 plate. I can't finish the counting. All the cells, there are only 7 colony forming unit present here. So this is less than 30, and I have 1 plate good to use. This plate is this number is between 30 to 300. Well, since I only have 1 plate to get the good statistic significant number, I will only use this number to get average CFU per ml. How to do this? This is since we only have 1 number, we divide by 1 since we only use 1 plate. So this is my average. This is my average of my unpasteurized raw milk sample. Okay, we need to write it in scientific notion. So this number equals 1.12 multiplied by 10 to the s. So we need to write in scientific notion as shown you here, and this is our concentration of our unpasteurized raw milk. Let's have a look of our pasteurized. This is our pasteurized raw milk samples from our 10 to minus 3 dilution, and here too many to count. How about this plate? I'm going to count this plate because maybe it's between 30 to 300, and I'll show you the number after I finish counting the cells. And this plate, you know how to count the cells from our 10 to minus 5 pasteurized raw milk sample. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So even this is very big, we still show that different bacteria has different colony shape. This is only 1 colony. So we finish counting is 11 from our 10 to the minus 5 plate, and we are since this is less than 30, I won't use this plate, and the 10 to minus 6 only 2. I won't use this plate, but but this number you need to input into your table for your 10 to minus 6 plate. This number you also need to input into your pasteurized raw milk table 10 to minus 5 plate. For the here 0. So this is our 10 to minus 4 plate from our pasteurized raw milk sample, and we finish counting the cells by marking a dot at the bottom part of your agar plate, and we are going to have 104 colonies present on our 10 to minus 4 plate. So you know how to get the safe concentration of your 10 to minus 4 plate is by multiply the number of colonies multiplied by the dilution factor 10 to the 4. And we need to write in scientific notion. This equals 1.04 multiply by 10 to the 6, right? Am I right? So this is the only number we are capable of using for our pasteurized raw milk samples. So please go ahead, input this number into your table and compare this number and of our unpasteurized raw milk sample. You know how to do the average CFU per ml, since for this batch we only have one number to use to do the average CFU per ml, and so this is the only number you are capable of using for your pasteurized raw milk. And for the unpasteurized raw milk sample, this is the only number you are able to use for your unpasteurized raw milk sample. So please compare these two numbers. Please compare these two numbers and see whether pasteurization works and whether it meets our standard accepted range of our pasteurized and unpasteurized raw milk sample. Please have the answer in your lab report, and we'll see the result.